briefing video for the Friedel Crafts experiment. So in the reaction scheme here, what we have is the reaction that's taking place. So it's electrophilic aromatic substitution reaction. The aromatic molecule that you're reacting is toluene, which is also going to be a solvent of this reaction. Okay, it's going to do an acylation with this acetic anhydride that we have here. So one of the carbonyl groups catalyzed by aluminium chloride, and you can learn about the theory of this reaction in your sort of organic lectures or textbooks. Now, the purpose of this experiment is to give you repeated practice of these core lab skills, you know, setting up a reaction under reflux, sort of do melting points, getting IR. But it's also here to introduce sort of new skills as well. So a variation of distillation is a steam distillation, and also this particular reaction needs to be run under sort of dry conditions, and so one of the things we do is we use syringes and needles to measure out sort of liquids in a way that we sort of don't leave them open to the atmosphere to absorb water. Okay, so it's really important that you watch the pre-lab videos to kind of show you how to do these techniques. In particular, with regards to needles, you have to watch the needle safety video, and you have this extra needle safety test to do on top of your normal pre-lab exercise. And this is because sort of injuries with needles are one of the most common forms of injury in the lab. Okay, so we don't want you sort of piercing your skin with a needle. Even worse, if it contains a chemical in there, then you could potentially be injecting a chemical into your bloodstream. Okay, so it's really important that you watch the needle safety video and complete the needle safety test, and then also look at how to handle needles and syringes and perform some of the other techniques correctly and safely as well. In terms of the structure and planning of this experiment, you've got 2 days to do this experiment, so you can think of it being broken up in this sort of way. In the first day, sort of setting up and running your reaction, doing the Friedel Crafts acylation. Then in the afternoon, starting to do your purification, so the steam distillation, and then in the following day, your hot filtration and recrystallization, and then just sort of running your analysis, your IR, NMRs, and melting points in the afternoon of the second day. Okay, so the reason why you need to keep this reaction sort of dry and free from water is because aluminium chloride is a key catalyst in the reaction, but it also reacts with water. So if it's going to react and degrade in water, then you're going to have less catalyst reacting and helping to facilitate the Friedel Crafts reaction. So then that will lead to a lower yield. So it's really, really important to keep your reaction sort of dry. Okay, so these are the things that we're going to sort of keep in mind for your setup to keep the reaction dry. Firstly, you're going to use a sort of multi-neck sort of flask. Okay, this allows you to attach things like thermometers to monitor the temperature of the reaction, but where it isn't open there. So you've got a screw top adapter to stop the to add your thermometer but not have it open to the air. On top of the condenser, again to stop this being open to the air, you've got a calcium chloride guard tube, and what the calcium chloride does is absorbs any sort of moisture that you have. So it doesn't completely seal it off. You don't seal off a reaction going to heat because there's going to be a build-up of pressure, but if there's any sort of moisture that comes in this way through the guard tube, the calcium chloride will absorb that, and that will stop any water getting into your reaction flask. And you're also going to be using anhydrous toluene. So this is toluene where it's sort of the water has already been removed. It's going to be in a sealed flask. It'll be sealed with a rubber septum, and so you can't just simply take the septum out and have the solvent sort of open to the air, because then it will just absorb the moisture. So instead, we use a syringe and needle to pierce the septum and withdraw the liquid that you need. Okay, so really important to have this sort of setup for the reaction. A little bit more complicated than what you've used before, but these kind of little extra steps that you're using will help keep the reaction sealed and not be open to air. And also using anhydrous solvent will mean that with these sort of steps, there's less likelihood that there's going to be sort of water present to react with the aluminium chloride, and you'll get better yields out at the end of the reaction. With regards to the steam distillation, okay, so the purpose of the distillation is to remove the toluene at the end of the reaction. So you use it to do your Friedel Crafts acylation. It's also a solvent of the reaction, so you're going to have a large excess of toluene in the reaction, and so when you finish with that toluene, because it's a liquid, because it's a solvent, you can remove it by distillation. But toluene has a high boiling point. It's above 100 degrees, and so what you do in a steam distillation then is you sort of combine water with the toluene. It's called azeotropine, and this helps the toluene to sort of boil off more easily than it would do on its own. Okay, so the key thing to remember about the steam distillation is that you are removing the toluene. So it's not a distillation where you are distilling a product and you're collecting what you want in the receiver flask. You're actually using the distillation to remove something. So it's actually what's in the original flask, the reaction flask, that's actually what you're keeping. That'll have your product in there instead. In terms of the key hazards of this experiment, again, it's really important that you keep checking the lab scripts. If you do forget what the hazards are, you go back and look in the script how to sort of use it safely and dispose of it safely before you actually use it in your reaction. But one of the key hazards is aluminium chloride. It reacts with water, but also it's corrosive as well. Okay, so you make sure you take the appropriate precautions. And as I mentioned before, needle injuries are one of the biggest sources of injuries in the lab. Okay, really important that you don't pierce yourself on these needles. So you must watch the needle safety video, complete the needle safety test, and this is an additional test that you must complete to be able to start the reaction in addition to your regular pre-lab test. And just one key thing to point out as well, when it comes to disposing the needles, okay, these cannot go into the regular sort of contaminated waste bins, because they will just simply pierce the orange bin bags. Okay, these need to go in a special sharps bin. You can see a picture of one here, solid plastic container. Okay, nothing can be pierced, and then when these are full, technicians can seal them so they cannot be opened or reused for other purposes as well. Okay, so as well as making sure you can use a needle safely, you've got to make sure you dispose of it correctly as well. Okay, so that's the briefing for the Friedel Crafts experiment.